Hello friends, today we will see singleton class demo and what are the ways to create the singleton class and how to break the singleton patterns and all these things. Okay, singleton, what is singleton? It is the creational design patterns, which means we will ensure that only one object is created of your class. If you go below to this document, I will show you some theoretical details about singleton class. We will see how many ways are there, what are the types of singleton, that is easy, eager loading singleton, lazy loading singleton, then what are the best ways to create the singletons, what are the patterns to break the singletons pattern, and how to prevent or breaking, and which singleton is recommended by Joshua Bloch, that is the creator of uh, very famous Java book. Okay, so we will see that all these things. Singleton, which means that you can create only one instance of the class entire JVM. For entire JVM, if it create two different instances of the class, then uh, we cannot say that it is the singleton class. If we go here, I will show you. Creating two instances should return same hash code, but it is returning different hash code. If we uncomment this one, okay, let's uncomment this one, singleton class demo. This is one singleton class demo. Okay, and let's say this singleton class demo, we created two instances of it and we are printing hash code. Okay, if we see what is the hash code of these two instances, then we can see those are the different hash code instances of that class. See, this number is different, right? So which means that uh, this is not singleton class. Okay, simply it is means that this is not singleton class. So laying, okay, so real world example. So you will ask what are the real world use cases of the singleton class. So we can say there are n number of real world use cases for singleton class where we use in day-to-day life of Java programming paradigm. Okay, so first is connection pooling object. Just imagine what will happen if your database is having multiple connection objects for connection class. So everyone will connect to the DB and he will create his own instance like this, and he will able to connect to the DB, and the DB will get mess up. Okay, and our connection will break at some point. So for DB connection pooling, our class should have a singleton class. So n number of people are creating the instances, they should get same instance while creating the while connecting to the DB, while fetching the details from DB. Okay, connection details should not be altered. Okay, that is one real world use case. Second is cache manager. Okay, suppose one cache is there, uh, and you are putting some values, some object inside those caches, and for storing the data and accessing the data, okay, for across the users, so there should be only one cache, right? So that every user is getting the data from the same cache. If the cache is created multiple places, then every user will not able to get the data by using cache. It will hit the DB again, right? So cache manager is another example. Logger is another example. So if you see logger factory dot get instance, okay, that method. So it is the singleton class. Making the report. Let's say you want to make some report for your JUnit test cases, and for constructing that report, you want to use any report class, and that should be a singleton class. And let's say thread pool is another example, effectively managing the pool of threads for concurrent tasks. So these are the some real-time use cases for your singleton class. If you create multiple instances of this, then memory waste, memory leak problem can occur. Okay, that's why all these things like logger, cache manager, connection pooling, making the report class, thread pool class, all this should be a singleton class under the hood. Okay, so What singleton class exactly do? It provides the single point of access to the class, generally using the get instance method. So there will be a get instance method, and that is the public method. And by using this method, you should able to get one and only one instance of the class. Okay, there are two types of singleton classes. One is eager initialization and another is lazy initialization. We will come to that part. What is eager initialization? In eager initialization, we create the object very first, okay, while loading the class itself. And in lazy initialization, we will not create the object at very first, and as per the demand we will create the object inside the get instance method. That those are the main basic differences. Okay, let's say we are using any eager initialization. Just now we saw, okay, this is singleton demo class, and we have created two instances of it, and we are printing the hash code. Two instances return the same hash code. If these two instances are returning the same hash code, then we can say class is singleton. But if you see in the screenshot, the hash code is different, right? If you see, hash code is not the same. That's why this basic is the not singleton class. That's what we saw in this first point. Okay, now, okay, as we can see, we have break. Okay, so eager initialization, we will see eager initialization first. Then we can move to the steps how to create the eager initialization singleton class. So if we see, singleton type is eager initialization and breaking it with reflection API. So we will first we will see how to create the eager initialization singleton class. If we go here, okay, create a, if you go to the step 2, create a basic singleton class using eager initialization. Okay, okay, so basic connection pool equal to new basic connection pool, not able to create the object since constructor is private. Okay, so basic connection pool is there. This is one class is there, and this is the eager initialization is there. So at the class level itself we created the instance of the class, and since the constructor is private, this is main objective of our singleton class. Our constructor should be private, so that outside the class people should not able to create the object of that class. If I am trying to create the object of this, see what it is showing. Basic connection pool has private access in this basic connection pool, which means it is saying that constructor is private. You cannot create the object. Giving same hash code to second objective achieved. Okay. So if we go to basic connection details, so what we made there, we created the instance, we make the constructor as private, and in get instance method, let's say what we have written the instance. Okay. Now, if we check the hash code of this, okay, if I uncomment this one, I created instance by using get instance method. And if we check the hash code, let's check the hash code of this. And if you see, hash code is same for the both classes, both the instances. So our objective is achieved, right? Hash code is same, but is that means our singleton is foolproof singleton? No, our singleton is not foolproof singleton. Let's see how to break this singleton class. We can break this using the reflection API. So let's go to this method, and here we created, here we got the instance breaking the reflection API, right? Breaking through reflection API. We can break this basic eager initialization using reflection API. So we have written this method, okay, break using reflection, and here we created the instance, first instance, and here using reflection to break the singleton, right? So basic connection pool, that is our singleton class dot get declare constructor. So what we will get? We will get the constructors. How many constructors are there? We will get all the constructor here. Let's say we got the our main declared constructor, that is private. Okay, so we are setting constructor dot set accessible true. By using this one, we are setting that constructor as accessible. Even if it is private constructor, then outside the class we are making that one as accessible as true. And This is the reflection API. And by using this constructor instance, we created another instance 2. And if we check the hash code of this, then these two hash code will be different, not same. If I run this program, then I will show you how the hash code is coming as different. Okay, so this is another hash code, this is another hash code, so hash code is different, right? So we, in this way, we can break our singleton pattern using reflection API. But we can prevent this breaking, we can prevent this singleton breaking using reflection API. Breaking of eager initialization singleton using reflection API is resolved using instance not equal to null check inside the constructor. So if you go to the constructor, if you go to the constructor of this, okay, and here we can check instance not equal to null, we need to do it. Okay, so if we add that instance not equal to null, protection against the reflection, it will provide you the protection against the reflection API. Okay, reflection break resolved inside the basic pool with reflex. This is here I will show you how we can prevent that one by adding that, if instance not equal to null, then throw new illegal state exception instance already created. Okay, so which means in reflection, what we will do in reflection, we will create the first instance, right? And once you create the instance, at that time, when it is trying to create another instance here, it will throw this error. Okay, illegal state exception error, it will throw. Okay, so let's go here and let's see what we added. If instance not equal to null, then throw new illegal state exception instance already created. This is the prevention for instantiation, and inside the constructor itself we can add this one. So first time instance will not null and it will create the instance, and second time instance not will be the null, and we can throw this error from that. If we go to our class breaking using reflection test, and if we run this one, then our hash code will come same. Okay, let's run this. Okay, uh, we will not able to break itself. Okay, sorry for that one. Uh, this is not hash code test, right? So new instance we are not able to create itself, and that prevents us for creating another instance for that. So our objective is resolved, right? So previously we were able to break it using reflection API, but now since we added what we added to this, if instance not equal to null, then if instance is not null, then we are throwing the illegal state exception. In this way, we have achieved our reflection break. Okay, so reflection cannot break this one. So now, but still we can break it using serialization and deserialization. Okay, if you go break eager initialization singleton class with serialization and deserialization, how to break it? How break work with serialization and deserialization? We serialize instance of a file using object output stream, then this write object state to byte stream, then we can deserialize it back to a new object using object input stream. This create a new instance by reading the object state from the byte stream. The JVM doesn't use the constructor, instead it create a new instance using the reflection. Okay, if we go here, I will show you that demo. Okay, we can still break it using serialization and deserialization. So let's see how we are able to break it with serialization and deserialization. If we go here, this is our class, right? This is our class, and let's see how we are able to break it with serialization and deserialization. Let's debug this code. So we are creating instance. break its serialization. Okay. Okay. Now we created one instance. First, get the singleton instance. We got the singleton instance. Serialize the instance to a file. Whatever instance one we created, that instance using the file output stream and object output stream, we are serializing that instance to a file. This is one file is here. Okay. Okay. Then go to next. So our object state is returned to the file. Now we try to deserialize it back with a new object. Okay, object output in equal to new object input stream, new file input stream, and same file we are giving singleton.acr. Here we, in which this file we able to store our instance details, right? State of the instance, same file we are using for deserialization. Okay, then let's see what is coming here. Okay, in dot read object we are reading that object, and instance 1 hash code and instance 2 hash code. Let's observe that those two objects are entirely different. Here the serialization is break is resolved actually. Okay, how it is resolved? By, you know, we have implemented this read resolve method. Okay, if we don't implement this method, then if you see, if you debug it again, then if you see, those two instances are different. Okay, then here object state is stored, then in.read object we are doing from that file, and if you see, instance 1 equal to instance 2, it is false, right? And if we run through it, if you see, again two different hash codes are created for two different objects, because deserialization, when we are doing deserialization, okay, if we go here, okay, while doing the deserialization, JVM doesn't use the constructor. Instead, it creates a new instance using the reflection. That's why we are getting two different hash code. So if we add the read resolve method, if we add the read resolve method to our singleton class, then we can prevent breaking by using the serialization. Okay. If we go back to our class, we can add this method now. Okay, read resolve. What is the syntax of this? At the rate serial annotation we need to add to read resolve method, then protected object read resolve, and return the get instance. Always return the existing instance from this method. Okay, from read resolve method, always return the existing instance. Get instance method we need to return it from it. Okay, so this is the case. This read resolve method we have added. What is the syntax of this read resolve method? Protected object, return type is object of this read resolve method, and protected object read resolve, R is capital, read second R is capital. Okay, read resolve, and from that method we are returning the get instance itself. Okay, so this method is called during the deserialization. Okay, so we are calling our own method from deserialization. Okay, that's why we are getting the same object. If we run this class again, then we will get same object hash code here. If you see, object hash code is same. In this way, we prevented breaking of our serialization class using the read resolve method using the serialization and deserialization. Can, so it can still, we can break the serialization. Okay, we can still break our singleton class using different approaches. Let's say lazy initialization. Now come to the part of lazy initialization and breaking with multi-threaded environment. Okay, so how to create the singleton class using the lazy initialization? Okay, let's go to this class. Okay, this is the initialization of the class. Private static. Okay, let's say I am not creating volatile. Let's say I am not creating this one. Let's say I am not creating this volatile. Okay, so here we have created one private static this class instance, and we have created this one, and then we created the private constructor, and then here instance equal to null. We have public static this get instance method, and that get instance method will return the class itself. All these things we have added. Okay, and this is the basic thing. Okay, lazy initialization steps. What we did for lazy initialization, we created the private static instance variable, private static basic connection pool with lazy initialization, basic connection pool with lazy initialization. Okay, okay, let's control it. I will show you. Okay, let's go to this basic connection pool with lazy initialization class. Let's go to this class, lazy initialization class. Okay, here we created private static instance variable, private static basic connection pool with lazy initialization instance. Here we are not eagerly instantiated our object. Okay, we created the private constructor and protecting the reflection attack from instance not equal to the and throw new illegal state exception we are throwing it. Then here public static method to get the instance, public static get singleton, and get instance method we have written, and from here if instance equal to null, first time instance will be null, and then we are creating instance equal to new our singleton class, and we are returning that instance. Okay, resolve method also we have added. Okay, so this is a basic class. Okay, and for proving that serialization and deserialization, our class singleton class should must implement serializable interface. Serializable is marker interface. Okay, no methods are present in this. Perfect. So basic connection pool with lazy initialization we did. And now we are trying to break it here. Okay, if we go to this one. Okay, basic connection pool with lazy initialization instances. We created one synchronized set, and instances we initialized with synchronized set for hash set, and we created countdown latch so that all threads start at the same time. So number of threads are 10. We've taken the 10 threads, and 10 thread can try to create the object of our class at the same time. Here we are trying to break our lazy initialization singleton class. Okay, with multiple threads. Okay, so we have written one for loop. It will return for 10 threads, and we are creating new thread each time. And here all thread will try to get the instance at the same time because we have used countdown latch here, and here it is taking the instance, and we are adding instances to the set. Okay, and we are printing here all unique instances if anyone are there, and we will check how many unique instances will get created or any duplicate instances get created. Once we check the hash code of those instances, then we will able to perfectly know what is happening there. Okay, so let's run this. Okay, Let's debug it. So we are trying to break the lazy initialization singleton in multi-threaded environment. Okay. So we created number of threads are 10, instances object we created, size is 0 initially. So we are adding instances, right? One by one. So all threads are starting. All 10 threads are starting here. Okay. Wait for the thread to complete. Okay. Now if we see, we got the instances in this. Unique instances we will print, and we can terminate the program. So unique instances, if you see, thread 31 got the instance with hash this. Thread 25 got the instance with hash this. So n number of instances are getting created with different hash. If you see, this hash is different, this hash is different. Okay. So if we run this one multiple times, right, we will get some different output. Okay. See, this one, this all hash are different, right? So see how many objects are getting created for our class. So we are able to break our singleton using the multi-threaded environment. In multi-threaded environment, this will not work, right? So how to prevent that one? Okay. So we are doing the lazy initialization, and now in multi-threaded environment, if multiple threads are trying to access our class, then easily we are able to break that thing. So preventing lazy initialization break by making whole get instance method as synchronized. We can how to prevent that one? We can make our whole instance of that get instance method whole method if we make at synchronized. If we go here in this class, okay, and if we go to get instance method, here we made whole method synchronized. Okay. So if we make this whole method synchronized, by making whole get instance method as synchronized, we can prevent the multi-threaded attack. Okay. Multiple threads will get the same value. If we see here itself, this method, one thread is coming and other threads will wait before this method only. Okay, other threads will not able to come. But there are some performance overhead for making, you know, whole method, whole get instance method as synchronized. Those performance overhead we will see later. Okay, if you check here, if we check here, breaking lazy initialization with multi-threaded environment, how to break, we have written here steps also, right? How to break it, right? Create multiple thread, 10 thread by default. Each thread try to get the singleton instance. Store all of 10 instances in a synchronized set. After all threads complete, check if only one unique instance is created or not. And we saw this one, right? Multiple instances are already getting created. So we are now trying to prevent this one, right? So how to prevent this one? By making, you know, whole get instance method as synchronized. So we have added the synchronized keyword to this get instance method. Since we have made whole get instance method as synchronized, then we will able to get only one instance of this. And if you see, hash code are also same, and unique instance is this one. If we go to our class, I will show you that one. Okay, let's comment out this one. Okay, if we go to this method, if you go to this class, then here we made synchronized get instance method, And if we run this class again, okay, so if we run this class again, then let's see what we will get. Okay, number of threads are 10. Then we created one instances set, initialize with 0. Then we created countdown latch. Countdown latch is created for starting the all thread at same time, and we are trying to create the instances, and we will add instances to our set. Okay, okay. Now if we see instances dot size, so only one, right? Only one instance is got created. And if we see singleton pattern is maintained, only one instance was get created, since we made our get instance method as synchronized. Okay, if we see this one, every hash code is same only, no duplicate hash code, even if multiple threads are trying to create the instance of your singleton class, right? If we run this multiple time also, okay, now see 29 429 429, only one instance. If you run it again, now created with 937 hash code, and only one instance got created. Singleton pattern is maintained, only one instance got created. Perfectly fine, right? So, but here are some overheads actually. Since we made entire method as synchronized, okay, so there is performance overhead. Every call to get instance acquire the release lock. Every call to acquire get instance. Suppose 10 threads are there and they are trying to acquire the lock. Okay, even after instances get created, this method is get lock. This can create a significant bottleneck in high concurrency scenarios. Most calls only need to read the instance, not create it. So other threads who just wanted to get the instance, right? They don't want to create it, but still they are waiting there on that, on top of that get instance method. Unnecessary synchronization. After the first call, the instance exists and won't change, right? After the first call, instance will not change, right? But unnecessary synchronize, every thread need to come through the synchronization and they need to wait it. Synchronization only needed during the first call when creating the instance. Subsequent call don't need the synchronization but still pay the performance cost. Other threads are waiting, right? So that is not a good approach to make entire get instance method as synchronized. So how to prevent that one? You can use double check logging with volatile keyword. Okay, as mentioned here in this class we have mentioned it. So if we go to this method, if we go to, okay, let me close other things. If we go to this class, right, here we have met volatile, private, static, volatile, singleton, instance. We created the instance with volatile keyword, private, static, volatile, singleton, class, and instance. Created the, see, if you see this one, performance override we already saw. Instead of making whole get instance method asynchronous, we can add double check locking. Double check locking, okay. What are the benefits we will get with double check locking? Performance is high, only synchronization the first time, entire method will not get synchronized, right? Thread safety also we will achieve n number of thread trying to get the create the instance, then only single instance will guaranteedly created. Efficiency also we will achieve, best thread safe and fast, and lazy initialization also we will achieve. So in this way we can save the memory also. Instance is created only when needed. So what are the steps? Add volatile keyword to the instance. If you see to the instance, we added the volatile keyword. Okay. Volatile keyword. What it will do, what it does, ensure that changes are visible to all threads immediately. Whatever the changes we are doing to this instance, then all threads, all other threads who are trying to access it, those will see that changes. Oh, if object is got created, right? So they will see, okay, object has is got created, so they will not able to try to create object again. Why needed? Prevent thread from seeing a partially constructed object. So it prevents to creating multiple objects, right? And benefit, what benefit we will get? Thread safety without full method synchronization. So we are not synchronizing entire method, right? So if we go here, we are not adding synchronized keyword to this get instance method. So here we are checking first if instance is null or not. Okay. And why this double check locking is needed? Okay. First null check. Why we added outside the synchronized class we have added, right? If we go here, so our synchronized start here, but before only we have added this instance not equal to null. Why we have added that one? What is the quick checkout locking? Okay. So outside the null check, we have added for quick checkout the locking without locking. Okay, here we are not locking it and we are checking whether instance is created or not. If the instance is created, then we will return that instance. We will not enter in this all all if statement. We will not enter in this, and the instance is uh, you know return from this. So locking will not come into picture if instance is already exist. See, if instance itself is not there first time, let's say first time it will come here. If you go again here, why needed? You know, performance improvement. Okay. So then we have added synchronized block. What it does, locks the class using instance creation. So now our instance is getting created, right? So it will lock entire class, this class, it will lock. Okay. So what we did inside that, synchronized and singleton dot class we have added, right? This is synchronized block. Okay. And why we added that one? That prevents multiple threads from creating the instances. Only one thread can come here and it will create the instance. Here also we have added second check, that's a double check locking, right? Second null check, why we added inside the synchronized bar, what it does, verifies again if instance is null. So sometime any thread has created any instance, okay, and we can return it, return it back. Okay. If it is null, then very first time, very first thread came and it is trying to access or create the instance of this class, then at that time this will also be null and we are able to create the object of it. If we put breakpoint here, I will show you the demo also. And this is the double check locking to ensure that only one instance is get created. Okay. Now, if I run it, one usage is there. And if I debug it, let me debug it. Okay. So double check locking. So we created the 10 threads. Similarly, as before, we create the instances set. We created the countdown dash to start the all threads at the same time. And let's start. Okay. Now, first time instance is null, right? First time instance is null. Only one thread came here. Okay. So one thread came and he's trying to create the instance. See, it is coming first time. That's why all instances are null. Okay. This condition also satisfy because instance itself is not there, right? This is the first thread. It is trying to create the instance. Now it will create the instance. Now we got the instance, right? See, this is the instance 864. And now if we go here, we are adding it in instances. Okay. Got instance with hash. Okay. Then again go here. Then if we see, only one instance got created. Okay. And multiple instances are not got created for this. Okay, let's put the breakpoint here. Let's debug it again. Okay, stop it. Debug it again. Okay, first time it came, instance is null. Okay, then what is happening? Go inside, came in synchronized block. Then first time instance is null. First time it created the instance. Okay, then we returning the instance. Okay, okay. If we see same instance, same hash code for all the instances we got, right? Means actually the only one instance is got created and same is returned for every thread. Perfect. So in this way, we are trying to prevent the multiple instance creation in multi-threaded environment using the double check locking. So still we can break our singleton using the clone method, right? So the clone method create a new instance of the object. This bypasses the singleton pattern in the single instance. Okay. The hash code will be different, proving two instances exist. If we go here, so till we can break the singleton classes using the clone method. You can still break singleton class if singleton class is implementing clone method. Okay. If we go to this method, so this is our singleton class, and let me close another method. So it is implementing clonable interface, right? This clonable interface is marker interface. Nothing is inside that. Okay. If it is implementing this clonable interface, and if it is, overriding this clone method, return at the rate override protected object clone, throws clone not supported exception, return super dot clone. This can create a new instance. So in this way we are able to break our singleton class. Even if we add the volatile, even if we add the double check locking, even if we add the read resolve method, everything is added, but still we able to break our singleton class and two different objects will get created. I will show you how. Okay, let's debug it. So for that, what are the rules? What are the rules? Your singleton class implement the clonable interface. This is one rule. If you go to singleton class, it is implementing clonable interface. And step 2, your singleton class override object class clone method. If you go to singleton class, it is overriding this method, right? Protected object clone, throws clone not supported exception, return super dot clone. Okay, so we can prevent this one also. How to prevent that one? I will show you. So let's see how it is creating. So we created instance. Okay, and by using the same instance, we are calling the clone method, right? And we created the instance too. And if we check the hash code of this will be different. If we see, hash code is different, right? Hash code is different of objects. That's why if we see, are the instance are same? False. Instance are not same. So we able to break the singleton using the clone method. So how to prevent that one? Okay, that is the question. So if we go here, so we can prevent the break with clone. We can prevent the break with clone method. Okay, if we go to here, preventing cloning and creating separate instances, we need to throw clone not supported exception from overridden clone method inside our singleton class. Okay, this is our singleton class. Okay, let's close this one. I will show you how to prevent that one. Prevent breaking singleton with clone method. Okay, let's go to this singleton class. So here we need to throw clone not supported exception. Perfect. As soon as we throw this exception, we will not able to clone the object and we will immediately get this exception. Let's check it how we will get that one. Okay, run the instance. See, clone not supported. Singleton instance cannot be cloned. Where we have added this one? Here. Singleton instance cannot be cloned. Inside the clone method, from the clone method, we are throwing two new clone not supported exception. Yes, in this way, we able to uh, prevent the cloning. But apart from this, all this creation of singleton easy and eager loading, there is very good singleton class and Joshua Bloch and Bill Pug. They have recommended this one to create the singleton class using enums. And why using enums? Enum singleton pattern is unbreakable in Java. No reflection. The JVM prevents creating enum instances via reflection. JVM itself is preventing, right? So no need to write that reflection related code here. No cloning. So cloning will not support it. Enum has final clone method already overridden that prevent the cloning and no deserialization issues. The JVM handles enum deserialization specifically to return the same instance automatically. No class loading tricks. JVM guarantee enum instances are created only once, even if across multiple class loaders. No constructor access. Enum constructor are by default private. Okay. So these are below some steps. If we go to our demo, let's comment out this one. Page singleton design is recommended by Joshua Bloch is enum singleton. Details can be found here. Okay. If we go to this method, okay. So here let's debug it. So here we are trying to get multiple instances. If we open this, this is public enum. Okay, this is not class. And this instance we created, right? What is that instance? Create enum with single instance. Okay, this is single instance, single enum instance. Okay, single enum instance we created. Private final. This is already private final, so no need to add it. Okay, so this instance we created. This is the most secure way of creating the singleton class in Java. It handles the serialization, reflection attacks automatically. No need to add it anything. Okay. Here we are trying to create the two instances by using the instance. Okay. Now we created two instances. Okay. But if you check the hash code of these two, 849, 849, or both the instances, we got the same hash code. Okay. So you are getting right how we ensure that only one instance got created. If you see the connection pool also inside that, it is using the 996, 996. Both instances are getting same things. If you go inside that, connection pool, array list 997, 997. Okay, triple nine 1000, triple nine 1000. Okay, in use false, in use false. Okay, all the objects are with same hash code, guaranteedly singleton. Perfect. So if we check the hash of these two instances, so instance 1 equal to instance 2, that is true, because see, these two instances are same, right? And that's why here we are checking the connection. Now we got the connection. Okay, this is 999 in use equal to true. So only one connection is used. So this is what is this connection and all. Okay, this is our real time scenario, whatever we saw initially, real time scenario, right? So in connection pooling, we used to create the singleton class, and only one instance got created. And by using the connection is established. Connection hash is this 122. By using the same connection, everybody will execute the query, and they will release the connection. And here we are trying to check the reflection attack. Okay, even if we make the constructor is accessible as true, and even if we are trying to create the new instance, we will get the exception straight away. Cannot reflectively create enum object. So we, as soon as we try to create the new instance of enum using the reflection API, we will not able to create the object, and we will get the exception. Reflection attach is prevented here, and in this way we created a foolproof enum singleton class, and that is recommended by author of Effective Java book by Joshua Bloch. Okay, so thank you. This is all for singleton class and which one to use. Thank you for watching. I will share the link of this document in GitHub repo, and please study this one. Okay, everything is added in this document. Okay, everything is added step by step. You can go through this document and learn, and happy learning. Thank you.